and the equation solved are both needed together in order to meet the achieved criteria. So let's have a look at how we solve a basic trigonometric equation. Here we have a very simple one, sine x equals 0.5. In order to solve that equation, I effectively need to get rid of the sine from the left-hand side. In order to get rid of the sine function, we're reversing what sine is doing there to x. We're going to use the inverse sine function, which reverses the sine function. Whatever we do to one side of an equation, we need to do the other. So we're going to do sine to the minus 1 of the left-hand side and sine to the minus 1 of the right-hand side in order to keep the equation balanced. Sine to the minus 1 is the button on your calculator. You will also hear this called inverse sine, and it can also be called arc sine as well. We're going to stick with the notation sine to the minus 1, and we're going to say inverse sine to be consistent throughout these videos. So we're going to inverse sine both sides of those equations. Now, it isn't necessary to write out this step. I'm just showing you how it goes. And what is left on the left-hand side is the inverse sine cancels out the sine, which is the point of it, and leaves x behind by itself. And then we have sine to the minus 1 of 0.5, for which we need to remember to be in the correct mode in your calculator. So you should be in radians mode to solve this, rather than in degrees mode. You need to head for your settings in your calculator and reset that to radians if you haven't already. And then x will be 0.52359, or more exactly, it is actually pi over 6. Either answer is acceptable. Let's look at something slightly more complicated. Here we've got sine of the function 4x, and that's also equal to 0.5. Now, in order to get at the 4x, which is inside the sine function, then the first step is going to be to inverse sine both sides there. That will leave the 4x behind on the left-hand side, and we do inverse sine of 0.5, which we already know is 0.52359, or pi over 6. That is what 4x is equal to, and so the final step there would be to divide both sides by 4 in order to leave just one x behind. X is equal to 0.13089, or pi over 24. Alright, here we have 2 lots of cos of x is equal to 0.4. And here there's a step we have to do before we can do an inverse cos or an arc cos of both sides, because the 2 is blocking us there. We've got 2 lots of cos x is 0.4, and so the first step that we need to do here is to divide both sides by 2. We cannot do inverse cos until we've done that. So if 2 lots of cos of x is equal to 0.4, then 1 lot of cos of x is 0.2. Now we can inverse cos both sides. X equals inverse cos 0.2, which is 1.36943. And we want to be giving these answers to 4 decimal places. It's important to be as accurate as we can in this standard, because when you use those answers and feed them into other parts of equations, then the more accurate that they can be, the better. So we will avoid rounding until the very last step of an equation. So here's something slightly more involved. 3 lots of cos of 2x minus 4 equals 1.8. So the first step here, similarly to the last one, is going to be to divide both sides by 3. We cannot inverse cos to get rid of that cos on the left-hand side until we've done that. So if we divide both sides by 3, then 1 lot of cos of 2x minus 4 is 0.6. Now it would be appropriate to inverse cos both sides, leaving behind that 2x minus 4 equals 0.9272, etc. Now we need to unravel that in the same way we solve an ordinary basic linear equation. We'd add 4 to both sides to leave 2x behind, and then the final step is to divide by 2 to leave 1 lot of x behind. And then we would round to 4 decimal places, as this is the final step. Okay, so